Hi, so in this video I'm going to show you a really simple Python implementation of the k-nearest neighbors algorithm. So before we dig into the details of the algorithm itself, first let me give you some sort of overview about how this whole thing works. So we have here our training data, which is just a data set that has a list of features and also a list of feature values where each feature value has a corresponding label. So as you can see here, the feature values are already in vector form, which means we can treat this as points or coordinates in a 5-dimensional space where the dimensions are defined by this list of features. So the features here are easy, AI, cis, thy, or morning. So basically we have the same machine problem we are dealing with when we were doing the binary tree model. Next, we have here our test points. So basically they are just points on the same dimensions or dimensional space, each with its corresponding label. So we're just going to use these points to test how accurate our model is. So in this line, we just initialize or instantiate our model. We feed the training data to the class, and then we also specify the k value, which is the number of nearest neighbors that the model is going to consider when it's classifying a point or generating a guess for a given point. And then in here we just call on the or invoke the method guess label to classify the point and guess for its label. And that's basically how this works. So let's get into the details of the KNN or k-nearest neighbor algorithm itself. So for me to show that, we're going to use the debug feature of VS Code so that we can make use of these breakpoints and look at the values of some notable variables. So let's just start that. So in here we initialize the class, we feed the data and also specify the k value. So it goes here and initializes the data in the initialization phase of the class or step. So as you can see, unlike binary tree model, k-nearest neighbor does not have a training phase because it only needs to calculate the distances between a given point to each of the points in the training data. So basically what happens is during initialization we just copy and store the training data, and that's it. So next we invoke the method to guess the label, and then we feed in the test point. Actually in this case we are using the second point from the test point. And then what happens next is, so in here we compute the distances. So given the point, we're just computing the Euclidean distance or the Euclidean distances between the given point to each of the points in the feature values or in the training data. So if we go to the next line, we can see that so the distances now is here. So it's just a tuple. The first item is the distance, and then the second item is just the point in the training data and with its corresponding label. So these are the distances. Here's another one, two. So as you can see, it's not sorted yet. So in the next line, we actually sort the data, or sort the data according to the distances computed, and the order is ascending from the shortest distance to the longest distance. So as you can see here, there's a 1, 1.4, 1.4, and then using the k value, which is the number of nearest neighbors we want to consider, we just get the, so in this case it's 3, the value of k is 3, so we just get the top 3 nearest neighbors. So the top 3 nearest neighbors have the following distances: 1, 1.4, and 1.4. And then, so what we actually need to do here then is to get the majority of the labels. So negative indicates hate or dislike, and 1 indicates like. So from these 3 nearest neighbors, we get the majority of the results of the labels, and the majority will be our guess. So a simple trick to do that is just to get the summation of those labels, and if we get a negative value, then we return -1. But if we get a positive value, meaning the majority of the labels are positive, so we just return 1 for positive. Or if the sum of labels is greater than 0, then our guess is 1, and then we just return the guess. So as you can see, the guess is 1 for this one. So we can say that the guess is correct if you compare it to the test point, or the actual label of the test point. So why don't we try to guess the label for this one, and let's see how accurate the model would be. So this one is at the 4th item. So counting from 0, we put here the value of 3, and then let me just disable or deactivate the breakpoints. And if we run this again, so the guess now is -1. Again, it got the correct label. And what if we use this one? So this should be 2, and if we run that again it's -1. And if we try the first item, run it again, so the guess is 1. So we could say that for all the test points, the classifier k nearest neighbors is able to get all labels accurately. So yeah, that's KNN is simple, but also at the same time effective. But there are also some cases where it fails, as discussed in our previous videos. So I think that's it. Uh, See you next time.